All right, this is going to be the last example I have for this lesson, so here's what we're going to do. We're going to evaluate this definite integral, the definite integral from -4 to 2 of x squared minus 3x minus 5 dx using the limit of Riemann sums. Now, I went ahead and wrote down the definition that I had on the other page. So remember, the definite integral can be equated to the limit as n goes to infinity, the number of rectangles goes to infinity, of the Riemann sum. And I gave this little definition, this little tidbit down here at the bottom for delta x and c sub I. Now, this is going to be a long example, so go ahead and settle in. You're probably going to want your calculator with you. All right, so let me go ahead and get started. I'm going to write down my steps as I go just to kind of coax you along and make sure you guys know exactly where I'm at in the process. So let me start off with step 1. Step 1 is going to be find delta x. Okay, so again, I have a formula up here for delta x. Delta x is equal to b minus a over n. So that's what I'm going to do. Now notice, a is the lower limit, b is the upper limit, and I'm going to divide by n, which is just a variable in this case. So b is the upper limit, which is 2, minus a, which is -4, the lower limit, over n. If I do 2 minus -4, I get 6 over n. All right, there's delta x. Good first step. All right, let's look at step 2. Step 2 is going to be find c sub I. All right, again, I got a formula over here. C sub I says a plus I times x. Again, I is just, it's an index of summation, so I'm going to use that a little bit later on when I try to do my sigma. But for right now, treat it like it's a variable. It is not the imaginary unit. Just be forewarned, that's going to come up in a second. So it's just a variable for right now. So a, we said, was the lower limit, so it's -4 plus I times delta x. Delta x was right here. It was 6 over n. So I'm going to go ahead and multiply that and do a little simplifying. So -4 plus 6i over n, all right? There's c sub I. All right, now that I've got that, here's what I'm going to do. That was step 2. Step 3, plug in. We're going to find f of c sub I. All right, so here I go. I'm going to take c sub I, which I just found, and I'm going to plug it into my function up here at the top. So I'm going to take -4 plus 6i over n squared minus 3 times -4 plus 6i n minus 5. I'm going to go ahead and I'm going to do as much algebraic stuff to that as I possibly can and try to combine as many like terms as possible. Hopefully you guys remember, when you square something, it's a lot easier if you write it out twice. That way you don't make any silly mistakes. All right, so here's what I'm going to do. I'm going to go ahead and FOIL or double distribute, whatever you want to call it. You can do the box method for all I care, as long as you're multiplying those two binomials. -4 makes 16. Then we're going to do -4 times 6i over n, so we're going to get -24i over n. Then I'm going to do the inside, so we're going to get the same thing. 6i over n times -4 makes -24i over n. Then we're going to do 6i over n times 6i over n, which is going to make positive 36i squared over n squared. Let me repeat again. It is not the imaginary term. You cannot say I squared is -1. Don't do it. Leave it alone. All right, on the other part, we're going to do -3 times -4, which is positive 12. We're going to do -3 times 6i over n, which is going to make minus 18i over n. And then that minus 5 is just there. Start combining like terms. 16 plus 12 minus 5. 16 plus 12 minus 5 makes 23. All right, then we're going to do the stuff with n's on the bottom. So I'm going to do this -24i over n, -24i over n, and -18i over n. So -24 minus 24 minus 18 gives me -66i over n. Then I've got just this 36i squared over n squared. All right. That's f of c sub I. Now, notice, come back up here in your formula, f of c sub I. We're going to have to multiply that by delta x. So that's actually going to be my next step. That's going to be step 4. All right, so I'm going to take that thing I just found, which is 23 minus 66i over n plus 36i squared over n squared, and I'm going to multiply that by 6 over n. Again, you're going to distribute here, so you might want to have that calculator handy. 23 times 6 is going to make 138 over n. Then we're going to do 66 times 6, which is going to make 396i over n squared. Then I've got to do 36 times 6, which is going to make 216i squared over n cubed. Notice all my n's went up by 1. All right, let me keep going. So we've got that part down. That's step 4. My step 5 is going to be apply the summation. All right, so I'm going to go ahead and switch to another piece of paper. I'm going to bring that over here just so I can keep working. So that means what I'm going to try to do is I'm going to try to take this and I'm going to do the summation from I equals 1 to n of 138 over n minus 396i over n squared plus 216i squared over n cubed. Now, here's the thing. In order to do this problem, there's going to be a couple of tricks that I have in handy for you. First and foremost, since the index is I, that is literally the only thing I care about, is just where there's an I. Anything that's not an I can be pulled out in front, and I'm going to break it up by terms. So here's what I'm going to do. I'm going to split it up first by terms. So we'll do I equals 1 to n of 138 over n. Then I'm going to do plus I equals 1 to n of negative 396i over n squared. Then I'm going to do plus the other summation of I equals 1 to n of 216i squared over n cubed. Let me repeat again. Anything that's not an I can come out. So everything here in this first term is not an I, so I can pull the whole thing out and just leave a 1. All right, then I'm going to do the next part. Anything that's not an I can come out. So we're going to do negative 396 over n squared. That comes out. And the only thing that's got to stay in is that I. All right, plus 216 over n cubed. Again, only the I has to stay in. That's I squared. All right, at this point, it would be helpful to know some summation formulas. Good thing they're on our notes. I wrote them all down. So if we just have a constant, we're going to multiply by n. Notice that's what I have in this first case. So I'm going to take 138 over n, and this summation right here just turns into plain old n. All right, the next one is an I. Well, good thing I've got a formula. This summation of I becomes n times n plus 1 over 2. So I'm going to keep this first part, which is plus negative 396 over n squared. And this summation turns into n times n plus 1 over 2. All right, this last one is an I squared. Again, got a formula for it. I squared, if you take the summation of it, it's going to turn into n times n plus 1 times 2n plus 1 over 6. All right, so this summation, that's what that's going to turn into. So I'm going to write plus 216 over n cubed. And I'm going to multiply that by n times n plus 1 times 2n plus 1 all over 6. Now that I've done that, I'm going to work on simplifying a little bit. Like, for instance, n on bottom multiplied by n. That's gone. We're down to 138. That was helpful. All right, I'm going to go ahead and keep doing some reducing. So I've got an n squared here and an n on top. I'm going to reduce that down to just plain old n on the bottom and n plus 1 on top. I can also go ahead and divide. Negative 396 divided by 2 should give me negative 198. So let me write that down. Negative 198, got rid of the 2. So I'm going to write down where I'm at right now. Negative 198 times n plus 1 over n. I'm going to come back to that in a second. Next part. Again, I've got another n right here, and I've got n cubed. So I'm going to bump that down to n squared. And I can also take 216 and divide it by 6. Hopefully you guys remember that was 36. We did that earlier. And All right, so I've got n squared on the bottom, and I'm still left over with n plus 1 times 2n plus 1 on top. Now what I'm going to do is I'm going to worry about some multiplication on top here for a second. So that's going to turn into negative 198n over n minus 198. All that's over n. On the other part, we're going to do the FOIL here, and we're going to just go ahead and distribute the 36. So n times 2n makes 2n squared, so I'm going to end up with 72n squared. I'm multiplying by the 36. Then I'm going to do n times 1, which is going to be n, so we're going to get 36 n's. Then I'm going to do 2n times 1, which is going to multiply by the 36 as well and get 72n. Then I'm going to do 1 times 36, which makes just plain old 36 over n squared. All right. What I'm going to do I'm getting to my last steps here. I'm going to break these fractions up a little bit just because I know they'll reduce. So like this is negative 198n over n. Well, that's plus negative 198 over n. I'm going to keep going. I've got 72n squared over n squared. I'll go ahead and combine 36 plus 72 makes 108. So that'll be plus 108n over n squared. And then I'll do 36 over n squared. Again, I'm going to work on simplifying these n's down. So that's going to be gone. That's going to be gone. That n turns that to from an n squared to an n. So let me write this down. 138 minus 198 plus negative 198 over n plus 72 plus 108 over n plus 36 over n squared. All right, one more step. Okay, I'm on step 6. Step 6, take limit as n goes to infinity. What's going to happen is everything that's over n is going to disappear. That means since I've got 138 minus 198 plus negative 198 over n plus 72 plus 108 over n plus 36 over n squared. If I take the limit as n goes to infinity of all that stuff, boom, it's gone. Boom, it's gone. Boom, it's gone. I'm left with 138 minus 198 plus 72. Math time. 138 minus 198 plus 72. Would you believe it? The answer's 12. That was a lot of work. Now, in the next lesson, lesson 1.3, when I talk about the fundamental theorem of calculus, I'm going to show you an easy way to do that because let's be honest, this was a nightmare. All right, see you next time.